Well, it is time for physics. So, you guys are going to have a unit test on the unit that you've just completed, except I know you're not too sure on vector components. Vector components has kind of thrown at least one of you, maybe both of you, a little bit. So, let's just go over as quickly as I can how to do vector components. So, here is a vector. We could call it, I don't know, x. If you split x into components, the only important thing to remember is they must be at right angles. That shows it's a right angle. It doesn't look much like a right angle. It's pretty horrible actually, but that is a right angle. Now if that is a right angle, we can have our two components of x. Well, let's just think about it. This would be x, let's call it v, xv for vertical, and this could be xh for horizontal. So two components. They are at right angles to each other. So what do we know about those two vectors? Well, if we had an angle, call it theta, it would be pretty obvious what we know about those two components. xh, there's the opposite, there's the hypotenuse, so we could just say xh equals h. Now, opposite over hypotenuse, it's going to be x sine theta. xv will be x, take a guess, it's the adjacent over the hypotenuse, so it's going to be cos theta. Okay, so that's the first thing to know. Any vector can be split into two components if they're at right angles. Show it's a right angle, and those two components will add together as vectors. They'll add together to give you the resultant. So that squared plus that squared will equal that squared. So you can always check. Alright, let's do a simple example. Let's rub this one out first. So, a projectile is launched. There it is. A projectile is launched with an initial speed of 48 meters per second. 48 meters per second, that's pretty quick. And it's at an angle of 30 degrees from the horizontal. So that might be a missile of some sort, or something launched out of a cannon, or just a ball that somebody's thrown, but it's travelling at 48 meters per second to start with at an angle of 30 degrees. Now your task is to split that into components. So how will you do it? You'll draw a triangle with a horizontal and a vertical, and you'll label them, well, this is 48, and this will be VH for horizontal, and this will be V, actually we should call them U, because initial speed is normally U. UH and UV. So, how would we calculate these? Well, we'd say UH equals it's our adjacent, here's our hypotenuse, so UH just equals 48 times what? It'll be cos 30 degrees, and 48 times cos 30 degrees on a Tuesday is 41.6 meters per second. Now at this point you stop and you do the common sense reality, does it really work check. So this is 48 meters per second, so this is going to be a bit less than 48 meters per second. It's not going to be hugely less, but it's going to be a bit less because it's on a bit of an angle. 41.6 is, a bit less than 48, so it makes sense. It fits the reality check. Now, let's do UV. UV. That'll be 48 times, it's the opposite this time, so it's going to be 48 times sine 30 degrees. 48 times sine 30 degrees. Now sine 30 degrees is just 0.5, isn't it? So it's going to give us an answer of 24 meters per second. 24 meters per second. Now, you want to check to see if this really has worked. So what you do is you go, hey Pythagoras, my old friend, come and tell me if I've got this answer right. So you go 41.6 squared plus 24 squared, and you see what that gives you. And if you do that on a Tuesday or on a Wednesday, you will get something extremely close to 48. Which just goes to show that vector components work. They can change your life. They can revolutionize the world as you know it. They can make a difference in your life. So learn vector components. Yes!